All right, in this video, I want to prove these trig identities over here. So let's start by taking a look at the first question. If I look at the left-hand side and the right-hand side, both of them are kind of complex because I have cosec on both sides. So in a question like this, I'm actually going to simplify on both the left side and the right side. So generally speaking, you only want sine and cos. I know that cosec theta is just the same as 1 over sine theta. That's a trig formula. So cosec square theta will be 1 over sine square theta. I'll leave the minus 1 the same. So this is working on the left side. And on the right side, I'll do the same thing. I'll convert the cosec square into 1 over sine square theta, and then it's just multiplied by cos square theta. Now the right side is a lot easier to solve for this. So I'm just going to solve the right side first. 1 times cos square theta is just cos square theta over sine squared theta, which is the only thing left in the bottom. And this is now fully simplified in terms of trig identities. So I can leave it like this. I'm going to solve this side over here. On the left side, I want to make a common denominator because usually if you don't have a common denominator, that's your next step. So I know that if I just have a regular number or expression with no denominator, it's always divided by 1, which means to make a common denominator, I'm going to multiply the top and bottom by sine square theta. So if I do that, I will have 1 minus 1 times sine squared theta is sine squared theta. And now I'll have a common denominator on the bottom, which is just sine square theta. Now, what can I do with 1 minus sine squared theta? Well, you should know the trig identity sine squared theta plus cos squared theta equals to 1. And this identity can be rearranged so that the sine square can move to the other side. So then I'll just have cos squared theta equals 1 minus sine squared theta. And then I can just replace the 1 minus sine squared theta here with cos squared theta using this trig identity or equation. So I'll just have cos squared theta over sine squared theta. And now you can see that the left side matches the right side. Therefore, we've proved this trig identity. Let's go to the second question in this video. If I take a look at both the sides here, I can tell that the left side is pretty much fully simplified. It has a common denominator. It only has a cos, no reciprocal identities, and there's nothing I can really simplify. So for this one, I'm only going to be working on the right side. So the first thing I'll do is I'll use the same formula as the last page. I'll turn cosec squared theta into 1 over sine squared theta. And then cot theta has two formulas. Cot theta is 1 over tan theta. But cot theta is also cos theta over sine theta. In order to know which one to use, you always look at the other side. On the other side, I don't have any tans, so I'm not going to use the first formula. I'm going to use the second formula. I'm going to convert this cot into cos theta over sine theta, and then this is all divided by the sine theta on the bottom. Now, if you're really good at dividing fractions by other fractions and things like that, you can do this instantly. But if you're not sure how to do it instantly, because the process is slightly different, whether you have a fraction in the top and the bottom, or if you have fractions in both places, you can always convert the major fraction sign into a divide sign. So 1 over sine squared theta minus cos theta over sine theta, and then it's divided by sine theta. So all I did was I converted this fraction right there into a divide sign. Next, I'll turn this divide into a multiply, and I will flip the fraction after it upside down. So if I flip sine theta upside down, remember there's just a 1 over here. It turns into 1 over sine theta. Now I'll just do my multiplication because according to BEDMAS, we got to do multiplication first. Cos theta times 1 is just cos theta, and sine theta times sine theta is sine square theta. And then they already have a common denominator here, so I can just combine like terms. So I get 1 minus cos theta over sine square theta. Now let me compare this to the other side. The other side is 1 over 1 plus cos theta, so I still have to simplify quite a bit more. The main thing is I got to get rid of the sine square theta. Using the same formula I showed on the last page, sine square theta plus cos square theta equals to 1. I can just isolate the sine square theta here, and sine square theta is just 1 minus cos square theta if I move the cos square to the other side. So I can change this to 1 minus cos theta over 1 minus cos square theta. And now you still can't cancel anything because of the negative signs. There's nothing in common. But I can factor this by difference of squares. You're not sure what I mean? If I have 1 minus x squared, this is from our factoring chapter, I can factor this to 1 plus x times 1 minus x. So knowing your factoring methods, especially difference of squares, and even common factor, really important. Knowing all your factoring methods, especially if your difficult class, is necessary to solve trig identities. So if I factor this by difference of squares, the bottom is just going to be 1 plus cos theta times 1 minus cos theta. Then I can just cancel the 1 minus cos thetas, and I'm left with 1 over 1 plus cos theta, which basically matches the left side. And now I've proved that the left side equals to the right side. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.